Hi everyone, it's Sorkin. Welcome to my channel. Today we are gonna solve LeetCode 560 subarray sum equals k problem. So today's problem is that we are given an array of integer sums, an integer k, and we need to return the total number of subarrays whose sum is equals to k. And we also given a clarification for the subarray. Subarray is a contiguous non-empty sequence of elements within an array. So we're given two examples. In the first example, we have 1, 1, and 1. So there are two ways, two subarrays, this one and this one, where the sum is equals to 2. Also, we have another example. 1 and 2 give us 3, and 3 itself is another subarray who gives us 3, and we are returning 2. But the important thing is to pay attention in this problem is constraints. In the constraints, we can see that we can use the elements in the array. They can be negative. Also, the sum, the k that we need to return, also can be negative. So that is going to play a crucial role in our the way we approach to solve this problem. Okay, let's go and see how we're going to solve this problem. Okay, let's take this example and work on it. So let's in this example, if we look at it, what would be the possible solution for this problem? The first idea that comes to mind is to use sliding window. We are adding 3, then we are adding 4. Our k is equals to 7. So 3 plus 4 is equals to 7. That's the first case. And then we are sliding our window and finding all other possible scenarios. But why it's not going to work in our case? The reason being is we have a negative elements. And since we have negative elements, adding the next element in the window not necessarily will increase the value of it. It may decrease. So that's why we cannot use the sliding window in this case. But what approach we can use? The approach we are going to use here is what approach we can use in order to solve this problem with the linear time complexity. The approach that we are going to use is we are going to use a hash map. It's not very clear first when you look at this problem that we can solve it with the hash map, but the more you look at it, you understand that we should use hash map in order to solve this with the linear time complexity. So what we're going to do here, we are going to use a sum, total sum, let's just call it total sum. Sum of the elements until the certain index. And we are going to check that after taking the 7 from that total sum, we are going to check that there is in our array, so earlier in our array, is there any combination where I can get whatever is left from that total sum after taking the 7, is that number exist in our hash map, and if does, so how many combinations of I can get that value. Let's go one by one. I think that it's going to be more clear. For example, the first one is that we need to add a default case for the sum of 0, so it equals to 1, so it always equals to 1. So let's take the first one. The first example is 3. So does 3 exist in our total sum? So no, we are adding 3, it's repeated once. So then we are adding the next element, 7. Does 7 exist? No, we are adding 7. And so first one is that the total sum minus k, and 3 minus 7 is minus 4. Minus 4 does not exist, so we are minus 4 is not in our array. And then we are going further, not in our hash map. So then 3 plus 4 is equals to 7. 7 is not, then we are adding 7. And also now total sum is equals to 7. 7 minus 7 is equals to 0. 0 means that it exists in our array and it equals to 1. So then our count here is equals to 1. So far. And then we are moving further. The next one is cumulative sum is equals to 14. 14 does not exist in our hash map. We are adding 14 and it's repeated once. And 14 minus 7 equals to 14 minus 7 is equals to 7. 7 exists and the count is 1, so we are adding plus 1. Now it equals to 2. So you get the idea, I think, that at this point, so what happens is we have the total sum. We are taking our sum from it, whatever our sum is. So our sum is 7. But in order it to work, we need to also that the whatever is left over from this total sum and k, whatever is left over, for example, in this case, 14 minus 7, right? That also should exist somewhere earlier in the array, because otherwise we cannot claim that we have case where our, for example, in this case, right, we have a 14 minus 7, so our total sum, and somewhere earlier in the array we have also 7 is the leftover. Somewhere earlier in the array we have this sum, 3 plus 4 is equals to 7, so it means that this one is another case. So we are adding, let's progress, and I think that it will be more clear. 14 plus 2 is equals to 16. So we don't have 16, we are adding 16 repeated once. Then 13 is repeated plus, then 16 plus minus 3 is equals to 13. 13 is repeated once. Then we are going to the next one, and for these cases, total sum minus k, there is no values. Total sum 16 minus 7, 9 is not here, and 6 also not here in the hash map, so we are progressing further. But for the next case, plus 1 is equals to 14. So what it tells us, 14, do we have that in our array? Yes, we do, and we are adding, so it means that until this point, we can have 14 combination of elements where the sum is equals to 14. It can be twice. So we have once here, and we have another case which is here, right? When the combination is equals to 14. So we are adding that, and we are increasing our count. And the total sum, why we are increasing our count? Because 14 is here, and the 14 minus 7 from the total sum minus 7 give us 7, and the 7 we have, and it's repeated once, so we are adding 1, then plus so 14, then 14 plus 4 is 18. 18 minus 7 is equals to 11. We don't have it, so we are progressing further. Plus 2 is equals to plus 2 is equals to 20. We don't have 20, we are adding, but the 20 minus 7 give us 13, which, yeah, we have 13, and we are adding to our count. So totally we get 4. Okay, that's how we solve this problem. Again, the idea behind it, it's not straightforward when you first look at this problem, but the more you look at it, how I can solve it with the one pass, it becomes clear. The idea is that we get a total sum, and from the total sum we subtract whatever our k is, and we are searching that, okay, can we earlier in the array, because for it to work we also need to find this whatever is left over, right? So let's call it just the leftover. So whatever is left over is that should exist, and the combination of the array, the amount of time, the count of how many times we can have the subarray equals to 7 is equals to how many times we can have, how many combinations of those leftover we can have. For example, if somewhere around here we are going to meet some value that is equals to 14, right, leftover, then it means that the 14 we can, at that point, we can have it twice. So there are two ways that how we can make it 14. then in that case we are adding 2 to our total count. One is, let's say that this scenario until here, and another one is somewhere around here. We can also have another combination which is equals to 14. That 14 plus our 7, that will give us that total number. That's it. I hope it's clear. It's a bit hard to understand first, but again, once you look at it and you try to break it down, it becomes more clear that we can solve it with the hash map in one pass. Okay, now let's go to the coding part. Okay, first thing that we are gonna do, we are gonna create a count is equals to 0, and we are gonna create a total sum that we are going to populate. Okay, so we have added the next thing that we need to do, we need to create a map with the key and value, integer and integer. So let's just call it map, and let's create a new hash map. And what we are gonna do, we are gonna go over our array. We are gonna say int I is equals to 0, I is less than nums length, and I plus plus. So for that case, we are gonna check if, we need to add the base case for our map put default case, put 0 and 1. Okay, we are gonna say, okay, if map contains key, if map contains key is, which is total sum, so we need to add here total sum, we are adding our value at the time, so I, then if our total sum minus k, if that is, if map contains it, so total sum minus k, then what we are gonna do, we are gonna add, so it means that so we have total sum. From our total sum we subtract our k, and let's say we have leftover, right? That leftover we should contain somewhere earlier in the map. If we have it, then it means that we can, that's a scenario when we can increase our count. So then the count is, we are adding to our count, map get total sum minus k. Okay, and then we are adding to our map put, we are adding our total sum, right? And we are getting from map get or default, default. So get total sum or default is 0 plus 1. So we are incrementing whatever the value is there. And then we are returning our count. Okay. That's it. Let's think that should be it. All right, great. It works as expected. And let's go over it one more time. So as you can see, implementation wise, it's pretty simple. The idea behind is that we are maintaining our total sum. So once we go over the array, first we are creating a hash map, and we are adding 0, 1 as a default case for the sum of 0 is equals to 1. So, and we are adding to our total sum, and from our total sum minus k, which means that at any point in the array, so if from the total sum we subtract our k, so our sum, and if we find that there are cases earlier where that leftover, where our leftover is equals to that number. So we have already added that, we have already solved that problem earlier. So as we have seen in the case of 14, right? 14 minus 7. So 7 is already exist. We have already solved that problem earlier. So we are, and how many combinations of that? Only there is a one scenario when we can get that 7. So we are adding that value to our count. And so after checking that, we are checking that if the total sum exists already. For example, in case of 14, it already existed, so we are increasing the value, or otherwise we are just adding the new total sum to our hash map, and at the end we are just returning the count. I hope it's clear. I hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.